All right. So the other examples we're working with here, we could do a similar kind of problem to what we were just doing in the last video in Skill 15. The change here is rather than be given sort of an angle value and one side length, what we're given here are just two side lengths, and we need to find the angle. We did some stuff pretty similar to this at the end of the last section, so this is kind of a repeat, but never hurts to see things more than once. So in this case, we've got a triangle. The values here, right, we sort of have side lengths 9 and 17, and then our perspective angle is here in the corner. From this perspective, right, the first thing we need to do is sort of identify which of these sides is which from the perspective of the opposite, the adjacent, and the hypotenuse. In this case, the 9 is across from the angle, so that's our opposite value. The 17 is the other leg, right? So that means it's going to be the adjacent. The side that's unlabeled here would be the hypotenuse. We also don't know the value for it. We could find it. We could use the Pythagorean theorem and find the missing third side if we wanted to, but it's not necessary to find the angle. We can just work with the two that we've got. In this case, the adjacent and the opposite. So which of our trig functions uses the adjacent and the opposite, right? We're trying to find the angle. So the setup would be tangent, right? And so the idea here is the tangent value. You see if I can hold this and write ever so briefly, right? So the thing that we know is tangent of the angle should be the opposite over the adjacent, right? So from the perspective of the inverse, right, the reverse function, the angle would then be the tangent inverse of the opposite over the adjacent. So what we can sort of set up here is the angle would be the tangent inverse of, in this case, 9 over 17, right? 9 is the opposite side, 17 is the adjacent side. A quick just division there, right, gets us the 9 over 17 would be something like 0.5294, let's say. And then just a quick visit to the old calculator. We should be able to do the inverse value here and figure out that the angle, right, the angle that sort of goes with this particular setup is going to be 27.9 degrees. So that's what we're working with. So using those inverse functions in this case, because we're given the opposite and the adjacent, we're using a tangent. Let's do another variation from the exercises, right? So again, you guys are doing the odds. So I'm going to look at number 12. And I've sort of redrawn the setup over here on my page. So here's our triangle, right? Sort of a tall, skinny. We've got 5.2 meters for the length on the bottom. We've got 10.4 for the length over here on the side. From the perspective angle, right, where our angle is sort of up in the top, what that means is 5.2 is across from that. 5.2 is our opposite. And then the 10.4 is our hypotenuse. So which of our trig functions uses the opposite and the hypotenuse? Well, that would be the sine function, right? So the sine of theta should be the opposite over the hypotenuse. For us, that would be, right, 5.2 over 10.4. These are sides that are sort of picked in particular because they're going to give us a 0.5 if we divide them, right? So the sine value here would be 0.5. If we're trying to then find the angle and reverse it, all we're going to do is say sine inverse of that value, right? Once we've divided and gotten the 0.5, if we do the inverse there, what we're going to get for the angle is 30 degrees. This is actually then a 30, 60, 90. You might be able to sort of pick that up if you caught on, right? If you remember from a couple skills ago, this would sort of be our x value, and this would be our 2x value, right? The triangle that has this sort of doubling happen from one side to the hypotenuse is our 30, 60, 90. So in theory, if you sort of have eagle eyes and you really remember the setups, you would maybe have anticipated that. But if you didn't, then you can just use the inverse function of your calculator and go from there.